We just finished subnetting several networks into smaller subnets, and we did this by changing the subnet masks. We presented these subnet masks in what's called slash notation. This is also known as CIDR or bit count notation because it represents the number of bits in the subnet mask. But what exactly does that mean? Well, in this clip, we're going to get a clearer picture of exactly what slash notation is and how it relates to dotted decimal notation. Our customer has asked us to convert 10,000 with a dotted decimal mask of 255,255,1920 to slash notation. Well, this is super easy. All we have to do is write out the dotted decimal mask in binary and count the number of bits that are set to 1. The network is 10,000 and the subnet mask is 255,255,1920. Now, the part of this we are interested in is the subnet mask. The network address doesn't matter at all because it is not going to change. We are only interested in the subnet mask. If you look at the first two octets of the subnet mask, 255.255, each of these octets is composed of 8 bits, which are all set to 1. So we simply add these together to get 16. Now, let's look at the third octet, 192. We write this out in binary, 11,000,000. Next, count the number of ones in the third octet that we just converted to binary. In this case, there are only 2 bits that are set to 1. Finally, add the result, 2, to the number of bits from the first 2 octets, 16, and the result is 18. The subnet mask in slash or bit count notation is 18. So the answer would be 10,000/18. Remember earlier I emphasized how important it is to know binary. Going from dotted decimal to slash notation is very easy if you know binary. So what about going the other way from slash notation to dotted decimal? Well, for that, let's look at our next customer request. The customer is asking us to address all links according to the layer 3 topology diagram. What we need to know is how to convert these subnet masks in slash notation to dotted decimal notation. I've circled these 3 in particular because they are /28, /29, and /30 subnets. And if you look at the rest of the subnets on the topology diagram, you'll notice that every one is /28, /29, or /30. So if we just convert these 3, we'll have the dotted decimal notation for the entire network. So let's start with 10.0.18.0/28. Again, we're only concerned with the net mask portion, not the IP network. The first thing we do is write out 28 binary ones grouped into octets. Moving from left to right, we have 8 ones, a dot, another 8 ones, another dot, and another 8 ones. That's 24 bits right there. 8 times 3 is 24. And then another 4 ones to make 28. Since each octet must have 8 bits by definition, the remaining bits are going to be zeros. Next, we convert each octet to decimal to get the dotted decimal net mask. Remember from earlier, all ones in binary is 255, so the first 3 octets are 255. The last octet is 11110000, which is 128 plus 64 plus 32 plus 16, which equals 240. So the subnet presented in dotted decimal format is 10.0.18.0, 255.255.255.240. Now, let's do 10.0.23.0/29. The first thing we do is write out 29 binary ones grouped into octets. So we have 8 ones, a dot, another 8 ones, a dot, and another 8 ones. Sounds familiar? And then another 5 ones to make 29 total 1 bits. And the rest of the bits are, of course, 0. Next, we convert each octet to decimal. The first 3 octets are 255. The last octet is 11111000, which is 128 plus 64 plus 32 plus 16 plus 8, which is 248. So the subnet presented in dotted decimal format is 10.0.23.0, 255, 255, 255.248. All right, last one. One more. Let's do 10.0.12.0/30. Write out 30 binary ones grouped into octets. So we have 8 ones, a dot, another 8 ones, another dot, and another 8 ones, and then another 6 ones to make 30 total 1 bits. And the rest are 0. We convert each octet to decimal. The first 3 octets are 255. The last octet is 111.111.00, which is 252. So, finally, the subnet presented in dotted decimal format is 10.0.12.0.255.255.255.252. All right, you're probably getting tired of hearing 255. So far, we've got /28 is 255 in the first 3 octets, and then .240. /29 is 255 in the first 3 octets, and then .248. And finally, /30 is 255 in the first 3 octets, and then 252.